So historically, my understanding of read-only and exclusive locks in ColdFusion has been, let's say, a little bit fuzzy. So I tend to lean on exclusive named locks all the time simply because then I don't have to really have a deep understanding for how locks interplay. But a couple of weekends ago, I was reading through the Ortus Solutions Learn CFML in 100 Minutes book, and they said something about read-only locks that I think finally made it click for me how these things work. And I wanted to see if I could prove that understanding to myself by putting together a demo. So what I have here is two pages. I have a read page and I have a write page. The read page creates a read-only named lock for counter lock. The write page creates an exclusive lock for named counter lock. So they're both going to be accessing the same shared resources here. And essentially, they're just going to be looking at this application.counter. The read page reads from that counter, and you'll see that the write page increments that counter and echoes it as well. Now, both of these pages can run at different speeds. By default, they run fast, which means that they just process and then refresh the page. If they access the page with the slow speed, you'll see that they sleep for 3 seconds, and both the write and the read do this sleeping. So we have these two pages, one reading, one writing with a named lock. Both can access the page fast, both can access the page slow, in which case they sleep for 3 seconds. So to put these pages in contention, I've created a higher level page that essentially just includes those pages as iframe. And you can see I have two read frames and one write frame, and they can both be accessed at different speeds. So let's jump over into the browser, and here you can see I have my 3 frames here, 2 reads and 1 write. So first let's take a look at the reads. What happens when we have 2 reads in contention? Well, if we start this one reading fast and we start this one reading fast, you can see that they both seem to execute quite quickly. And now if we change this one to be slow, what you can see is it is sleeping for 3 seconds between its reads, or as part of the lock itself. And what we can see is that the other read does not seem to be affected by this whatsoever. The fast read continues to read fast while the slow read reads slowly. Okay, so now let's start a fast read and a fast write. So remember, the write has an exclusive lock. Now, because they're both executing fast, we can't really see that there's any contention here. But now watch what happens when we start to read slowly. When we read slowly, not only is the read executing slowly, but now the write lock, the exclusive lock, is forced to block and wait for the read lock to be released before it can gain exclusive access. So a slow read affects even a fast exclusive because the exclusive has to block and wait. All right, so now let's try to have a fast read and a slow write. And you'll see that we get pretty much the same outcome. In this case, once the exclusive lock has access to the shared area of the code, the read-only access has to block and wait for that slow exclusive access to release the lock before the read lock can be acquired. So when we have a named lock with read-only and a named lock with exclusive, both of those have the ability to block each other because the exclusive has to wait for all the reads to finish, and the reads have to wait for all the exclusives to finish, the writes to finish, right? And then of course if we have a slow read and a slow write, it's basically the worst of both worlds, because now the exclusive lock has to wait for the read-only locks to finish, and the read-only locks have to wait for the exclusives to finish, and everything slows down. So obviously you want to make sure that your access code is as fast as possible. But hopefully this has helped illustrate the interplay between the read-only and the exclusive locks in CFML, and specifically how a slow access pattern affects the other types of locks that are waiting to acquire access to that shared set of code.